Okay, so for 14.6, H2SO2 plus OH minus HSO2 minus plus H2O. So usually the rule would be H2O and OH, they wouldn't change in oxidation state, and you'll see it once you start doing them. They won't.
Miss,
Yeah.
are those 2s or 3s? This H2SO3?
Is this, am I seeing it again? It's the pixelation. Are they both SO3, HSO3? Yeah, Jim? Because it's the pixel.
That's what I took down.
Yeah, no, that's fine.
Yeah, they are.
Okay, that's fine. So this will be -2 and this is going to be +1. So you'll see that the OH minus and the H2O, when we start balancing equations, they are never going to change. So here we have, this is -2. You have 3 of them, -6. Must mean this whole other side is +6. This will be +1. You have 2 of them, +2, which must mean the S here is +4. Over here, -2. You have 3 of them, -6. I have to have 1 left over, -5. This is going to be a +1 and this is a +4. So there is nothing oxidized or reduced because the S's are the same. Is that okay? Take that as a yes, Eva. So for the Cu2O plus 2H plus goes to Cu plus Cu2 plus. If there are people that are happy with this, you can go on to the Chemistry Live workbook questions. I think it starts at W14.1. It's your personal choice. So -2, +1 here. The Cu2 plus is the rule. It has of its, if it's a simple ion, it has that charge. Copper here is 0. This is +1. This is a -2. This must be +1. So then we look at it, and here copper on this left hand side is being both oxidized and reduced. So from +1 to 0 is a decrease in oxidation number. This is reduction. And from here it's +1 to +2, which is an increase in oxidation number. That is oxidation. So you can get things that will be both oxidized and reduced across an equation.
Miss, would the H plus not be +2 because it's H and then there's a plus as well?
Okay, but when you're doing your piece of maths, you are calculating for, we're ignoring the 2 because you're calculating the oxidation state of just one H plus.
No, but the other way, it's like H plus, and the plus is an extra 1, and then H is usually +1 anyway, so not be go up to +2 because
no,
plus is 1.
No, so this falls under the rule for simple ion, which is, if it is a simple ion, it carries the charge of the simple ion. So this isn't H as in H2O, this is in H as in, or H plus is in a proton. So you follow your rules. Can I just ask somebody to help me out for this bottom one? Is it NO3 minus?
Yeah.
Thanking you. 3Ag plus NO plus 2H2O. So -2 +1 for your hydrogen, -2 here, +2 for your nitrogen. Your silver will be a +1 because it takes the rule of a simple positive ion. Here this is -2. I have 3 of them, -6. I need 1 left over, -5. This makes this nitrogen +5. This will be a +1 because it's a simple ion, and this is 0. So matching my silvers, I'm going from 0 to +1, which is an increase in oxidation number. It makes this oxidation. And I am going from +5 to +2, which is a reduction or decrease in oxidation number. It is a reduction. Happy, Eva? Okay, so moving on, is it okay to go to 14.7? So 14.7 is 2HgCl2 plus SnCl2 goes to Hg2Cl2 plus Sn. I'm going to say Cl4, or is it Cl6? I'm going to say it's 4 because that balances it. So chlorine is going to be -1. I have 4 of them. It must make tin +4. Here, chlorine -1. I have 2 of them, -2. This side has to be +2 in total. Each mercury has to be +1. So -1, 2 of them makes tin here +2. -1, 2 of them makes mercury here +2. So your mercury here is going from +2 to +1. That is a decrease in oxidation number. It's a reduction. Your tin is going from +2 to +4, increase in oxidation number, oxidation. NH4NO2 goes to N2O plus 2H2O. So -2, +1, -2. There are...
It's NH4NO3.
Thank you, Eva. So here it's -2. I have 2 N's on the other side. Each one must be +1. So this one, I'm going to break this one apart. So NH4 has to be NH4 positive. It's a complex ion. So each one here has to be +1. You have 4 of them. You have to have 1 left over. Am I doing this right? See it in my head. Yeah, this is right. This is -3. The NO3 is also an NO3 minus, so -2. I have 3 of them, -6, 1 left over, -5. This is going to be +5. So on this side we have this nitrogen going from -3 to +1, which is an increase in oxidation number, so that nitrogen is oxidized. We have this one going from +5 to +1, which is a decrease in oxidation number. That one is reduced. Okay, the last one then, 3Cl2 plus 6 OH minus goes to 5Cl minus plus ClO3 minus plus 3H2O. So here it is a -2 and a +1. Here it is -2. There are 3 of them, -6, and I have to have 1 left over, -5. Makes this chlorine +5. This is the rule for simple ions, so it's -1. This is -2. This is a +1. And over here, this is a 0. So here my chlorine is going from 0 to -1. It is a decrease in oxidation number. It's a reduction. Here my chlorine is going from 0 to +5. It is an increase in oxidation number. It is an oxidation. Okay, so if you would like to try, are you gone big on me? Nope. Okay, you happy with that? So now we're going to go on to the 14.1 and 14.2 in your Chem Live workbook. So you can keep working away. Mikey, turn off your mic, man. So if you're a fast individual and you have the Chemistry Live workbook, we're going up to 14.6.
Which all pages in the Chem Live?
No, but it's not in the Chem Live book, it's in the workbook.
Oh, okay.
Sorry, Miss. What exercise are we going up to?
Let me just double check again. Can't see this now. Hold on, I can't see it because the resume thing is in my way. So I have to go in another way. Give me a second. Have you just lost your share? Or you can still see it? Okay. I think it's 14.7, Jim. So 14.3, 14.5, 14.6, and it seems to go miss 14.7 and go to 14.8. The first four. So I'm going to start putting them up. So N2 has to be 0 because it's an element. The PCl3, the Cl will be a -1. 3 of them means the phosphorus is +3. Carbon monoxide, the oxygen is -2, carbon is +2. In CO2, oxygen is -2, carbon is +4. Aluminium, because it's an element, is 0. OF2 follows the rule that says fluorine is always going to be -1 in the presence of oxygen. So in this case, oxygen becomes +2. And the rule still applies when it's O2F2. So this time, fluorine is -1 and oxygen is a +1. In FeCl3, the chlorine is -1. 3 of them -3 makes the Fe +3. In the potassium chromate, oxygen is -2. There's 4 of them -8. It means the left-hand side has to be +8 overall. Potassium, because it's group 1, will be +1. I have 2 of them, which means the chromium is +6. S2- follows the rule for simple ion, so it's going to be -2. pH3, the H will be +1. There's 3 of them, which makes the phosphorus -3. The KiO3-, oxygen is -2. There's 3 of them, -6. That makes the left side +6. Potassium follows it's in group 1, so it's +1, which makes the iodine +5. In the cobalt chloride, the chlorine is -1. There's 2 of them, so that makes cobalt +2. In the SO4 2-, oxygen is -2. There are 4 of them, -8. I need to have 2 left over, -6. It makes the sulfur +6. In the sulfite, again, -2 for oxygen, 3 of them, -6. 2 left over, -4 makes the sulfur +5. In the chromium sulfate, to do it quickly, the sulfate has to be -2. Overall, there's 3 of them, which will make the chromate -6 left over. So, the sulfate -6 in total, which makes each chromine worth +3. And when you look at a sulfate by itself, it's a 2 negative overall charge, so sulfate -2, 4 of them -8, has to be -6 to have 2 left over, which makes the sulfur +6. For the NaH, that follows the rules for metal hydrides, so hydrogen is +1 and sodium is -1. Am I going at the right speed? Or are you... Yeah, you're all ahead of me. Thanks, Hannah. Okay, so in glucose, oxygen is -2. There are 6 of them, -12. Hydrogen is +1. There are 12 of them, +12. So the oxidation state of carbon in this is 0. For the aluminium oxide, it's -2. There are 3 of them, -6. It makes both aluminiums +6. Each aluminium is a +3. In copper sulfate, sulfur is -2. Copper is +2. In Cu2S, again, sulfur is -2. It makes each copper +1. For the calcium phosphate, so the phosphate is PO4 3-. You have 2 of them, it makes it 6 negative overall. Each carbon must therefore, or calcium must therefore be worth +2. And then just looking at the PO4 as a 3-, it is -2, you have 4 of them, -8. To leave 3 left over, it has to be +5. And the final one for the IF2, fluorine, most electronegative, is -1. There are 7 of them, -7. It makes the iodine +7. In 14.2, N2 is an element, it's 0. In NH3, your hydrogen is +1. There are 3 of them, means the nitrogen here is -3. In the NO, oxygen -2 makes the nitrogen +2. In NO2 is -2, you have 2 of them, -4, makes nitrogen +4. In N2O, oxygen -2 means nitrogen in total is +2, each nitrogen is +1. In N2O4, oxygen -2, 4 of them, -8, makes both nitrogens +8, each nitrogen +4. In NO3-, again oxygen -2, 3 of them, -6, 1 left over, -5, makes nitrogen +5. And NO2-, each oxygen -2, 2 of them, -4, 1 left over, -3, makes the nitrogen +3. So I think this is 14.4. Why are you not writing? Okay, so having a look at HCl, chlorine will be -1, hydrogen +1. In case ClO3, oxygen is -2, you have 3 of them, -6, makes the left hand side +6. Potassium, because it's group 1, is +1, which makes chlorine +5. In In KClO4, oxygen -2, 4 of them -8, makes the left side +8. Potassium +1 makes the chlorine +7. Chlorine, because it's an element, Cl2 will be 0. In ClO-, oxygen is -2. I have to have one negative left over, makes chlorine +1. And in ClO2-, oxygen -2, 2 of them -4. I need to have one left over, -3, makes chlorine +3. Happy to go on to 14.4 for those of you with your cameras on? Yeah. Okay, so for the BRF3, fluorine will be the -1 because most electronegative. I have 3 of them -3. Bromine is then +3. Chromium here, oxygen is -2. There are 7 of them -14. Makes the other side +14. Potassium is +1 each. So 2 of them +2, which makes the 2 chromium worth +12, each chromium worth +6. And the sulfur in H2S2O7 is oxygen -2. I have 7 of them -14, makes the left hand side +14. The H2 will be +1, so that's +2. It makes the sulfurs +12, each sulfur +6. Okay. So here are these two. So this thing up here, this potassium iron cyanide, this is what's called a complex. So there's a whole load of chemistry that goes with these types of things. They usually have transition metals in them, and we don't really, or you don't really see them in Leaving Cert, but you see them when you get to university. So it's a cool, there's cool chemistry behind it. So cyanide, we already have that in our complex ions. It's -1, so all 6 cyanides -6 makes the left hand side of this worth +6. The potassium, all three of them will be worth positive 3, which makes the iron worth positive 3. And here the copper chloride, this would also be a complex. There would be some other metallic element out here, but we're only just seeing it as an ion, so it's the square brackets are the giveaway. So chlorine is -1, 2 of them -2. I have to have 1 negative left over. It makes copper positive 1. And down in our bottom row, hydrogen will be positive 1. There are 4 of them, positive 4. I have to have 1 positive left over, positive 3. It makes nitrogen -3. In your H3PO4, oxygen -2, 4 of them -8, means the left hand side is positive 8 overall. Each hydrogen is worth positive 1, means the phosphorus is positive 5. And in terms of your thiosulfate, it is oxygen -2, 6 of them -12, makes the left hand side positive 12. Sodium is positive 1 because it's a group 1, so that leaves positive 10 for the sulfurs, and each sulfur is worth 2.5. So I'm going to stop my share if that's okay, and see your lovely faces. Alrighty, so there will be